Hey, what's up guys? Hope everybody's doing well and having a great day. In this video, we're going to take a look at the everlasting debate. It's been going on for years. It will probably continue on for many more years to come. The flat Earth, flat versus round. And then, of course, the Nemesis theory, a lot of theories around the second sun. I get photos quite frequently of, what looks like maybe a second sun in the daytime sky. Myself personally, I have for a long time, have always just thought, and again, it's just a theory, I can't prove it, but yeah, I think all of this requires a second sun, In fact, a lot of what I've read, most of the star systems in the Milky Way galaxy, the ones that we know of, are of binary star systems. The thing we're going to talk about in this video is the flat Earth versus the round Earth. I know a lot of you guys have theories on that, and that's been a debate for many years. And, I have a theory too. It's just not something that I've ever really talked about because, to me, I don't know. I guess it's debatable, and we're going to look at it in this video. We'll take some questions. I want to see what your guys' thoughts are. I'm just curious. That's all. I want you to be thinkers. You don't have to think like me. And I know all of you do have opinions, and you're all very smart. If I ask you guys a question about something regarding, a variety of topics, eventually one of you will figure it out. Just like that creature the gentleman sent in from California. You guys figured it out within an hour, and it was a horsehair worm. I was very impressed that you guys, I was not surprised, but impressed again, at the depth of your knowledge, and very impressive. But again, back to the flat Earth versus round Earth. And then where is Nemesis? I want to read a couple of articles that I found interesting. One out of Harvard physicists, astronomers reveal a second sun may have existed in our solar system, a long time ago. And again, this is just a theory, but based off of scientific knowledge from a team of astronomers from Harvard. And they think in their theory that it may no longer be around. It's not as easy as going out and taking a picture of it in the sky and voila, there it is. Me personally, do I think one's there or did we have one? Of course, I do. I think it's a requirement. I think it's still there. I don't necessarily think it was. I think it still exists. It's just that we can't necessarily see it. And I'm not so sure that it's even possible to be seen. I've always thought that it would require very complicated math to even find out where this thing may be. And a lot of other variables involved, but I don't think it's as easy as going out and taking a picture. Probably would require some sort of infrared technology to even detect where it's at. But I think we would see signs of its existence, because most of the stars in the solar system are binary star systems. In fact, some of them are trinary star systems, 3. So I think one is kind of uncommon. And I don't know why ours, being a binary, is looked at as being so bizarre. I don't think it's bizarre at all. Honestly, I think it's a requirement for a solar system to function properly. There has to be 2 primary stars, a primary and a secondary. Like in our case, maybe our sun's the primary and Nemesis, it's got a lot of different names. Maybe it's the secondary. But I do think it's out there somewhere. The scientists, they say we can't see this second sun. Scientists believe that if it did exist, it moved away from its orbit with our sun, billions of years ago. Studies of astronomy indicate that the 2 suns would have circled the Milky Way galaxy over a dozen times since then. After the second sun broke away, it may have ended up. Now, these are Harvard scientists, not me. They're saying this. After the second sun broke away, it may have ended up in a different area of outer space. However, the Oort cloud, a hollow sphere of debris that includes space rocks and comets in the outer section of the sun's orbit, could hold clues about this mysterious twin that a lot of us call Nemesis. And they're right. You know, the Oort cloud would react to the energy from a close binary star. I think it would. I think we'd see an increase in comet activity because there are a lot of comets in the Oort cloud, and they go on to talk about that. I think we would see distortions and anomalies in the Oort cloud. The Oort cloud is a wonderful place to look if you've got the equipment. It's kind of a, you know, external guard for the solar system. If you see an anomaly in the Oort cloud, then you know something's out there. If you start to see an increase in comets and various asteroids and things like that, primarily it's made up of icy bodies. You know something's there. The planets, goes on to say, astronomers explain the Oort cloud. The planets and asteroids in the inner solar system lie on a single flat disk around the sun. However, the Oort cloud forms a giant sphere of debris that surrounds the solar system. Also, while gravity strongly influences the inner planets, the rocks and other debris in the Oort cloud don't experience much of the sun's gravity. All of these objects could quite easily drift farther out into space because of this. Scientists have found that most distant objects in the Oort cloud are 100,000 times farther away from the sun than the Earth. Study co-author Dr. Avi Loeb, a Harvard astrophysicist, said that this distance measures halfway to the nearest star, Alpha Centauri. He went on to say that if this star and all of the others have Oort clouds, then they're all connected and space is full of them. While our Oort cloud doesn't have as many large objects as the inner solar system, it still contains about 100 billion individual items. Most of them consist of rock and ice and sit in the cloud debris. If you were to fly through the Oort cloud, you probably wouldn't come across anything at all due to the size of the objects. Loeb said, "We can't see the debris with our eyes. However, the evidence for them lies in the comets coming from the Oort cloud that move to the inner solar system quite frequently." One thing I've noticed is that when we have a large solar flare emanating from the sun, you'll see an increase. Not always, but a lot of the time you'll see an increase of sun diving comets. What's inside the Oort cloud? Some bigger objects also exist within the cloud, though not as many as the inner solar system. Scientists have been studying the Oort cloud beyond Neptune and have theorized that a planet may exist, pulling the debris into a specific formation. And that's what I'm talking about that anomaly. If there were a planet actually out there near the Oort cloud, it would create an anomaly moving around debris into specific formations or even into the inner solar system. Planet 9, as they call it, would weigh up to about 10 times more than Earth if it exists. And Planet 9 would be part of the secondary sun. Look at it like this. If the sun, look at our solar system and look at the very farthest planet away from the sun, like Neptune, Uranus. Well, if there were a planet associated with an outer planet associated with a Nemesis, second sun, let's say its outer planet, like our Neptune, Uranus, say it maybe gets real close to the Oort cloud, even though it's orbiting the second sun that we can't see, it could influence the Oort cloud at times. Loeb questions how the Oort cloud came into existence in the first place. In astronomy, many scientists believe that the debris is scattered from the disk of gaseous materials that formed our planets. Our Oort cloud makes up the vast part of our solar system, and it extends far beyond the customary reach of asteroids and planets. Billions of comets exist within this cloud. And it goes on to talk more about the Oort cloud and the possibility of a second sun. Really good article here, one that I recommend reading if you're into this type of thing. And I know most of you are, and a lot of you too have an opinion, just like me. We can't prove anything, But I do definitely believe that there is a second sun out there somewhere. If not still, working with our star, like these guys say, the Harvard physicists, they say there was one, but they theorize that it's probably not anywhere in our cosmic neighborhood anymore. And they definitely say you can't just step outside and see it, which that totally makes sense. I agree with that as well. Like you'll see a lot of images like this. And what this is, guys, I see these probably on a daily basis, at least multiple times a week. This is a photo of our sun. And what you see over here on the left is the sun, this bright object here, without the extreme bright light. And more than likely, this photograph was taken from behind a glass. And this is nothing more than a reflection of the sun without the bright light. I see this all the time, and if you can replicate this yourself, don't ever look at the direct sunlight, but if you take a picture of the sun looking away from behind a window or even inside of a car, any type of glass, you're going to get this type of anomaly that shows up in your photograph. So that is not a planet. That's not a second sun. Our second sun, in my humble opinion, would require unbelievable mathematics to even find out. You'd have to backtrack history is what you'd have to do. And you'd have to go back as far back as records could take you, and then go back some with computers to try to find out, where this thing may be today, if it even exists. But that's not it. That's a reflection. So if you ever take a picture of the sun behind a window, especially inside your house, that's going to show up not part of the time, it's going to show up every single time. Yeah, it's just the way it is. It's just how the light works. And we're going to take a quick look at the flat Earth. I know a lot of you have, opinions about the flat Earth, and so do I. I just don't really talk about it too much. I want to show you a couple of slideshows that I put together. And I've had this video for a while. It's a video a gentleman took while flying basically above the equator during the equinox. Okay, and he just happened to be up in this airplane 35,000 feet in the air at sunrise. Now check this out. Look at the way the light behaves as he's filming the sunrise, what the very early stages of the sunrise. Watch how the light behaves, and we'll take it from there. So this is where the gentleman was at. There he is in an airplane. Pause it real quick, and he's looking to the east, and you can see how the sunlight is beginning to stretch across the horizon, but it's being directed to the left, and it's being directed to the right. Okay, I'm going to continue on. It's just like a little 20 or 30 second video footage sent in by Radico. This is a sunrise at 35,000 feet, right around 6 a.m. or so. You can clearly see the sun hasn't eclipsed the horizon just yet, but you can see the light scattering. It's being directed by something, right? To the left and to the right. It's being directed by the Earth itself. So as the sun gets higher, which he didn't, continue on with the video, he just sent me this, which was, a great learning tool, because you can see that the light is being influenced by the Earth itself, and that would have to be a curved Earth. Otherwise, the light would be coming straight up. It wouldn't be influenced to the left, and it would not be influenced to the right. So what that video shows you is an example of how the Earth is more than likely curved. Here's yet another example sent in by Sandra T. And this is either a sunrise or a sunset, and it too involves the curvature of the Earth, and it's scattering the light to the left, and it's scattering the light to the right based on the curvature of the Earth. Here's another example of light, shadows. You can see the termination line here. They call this the terminator, where daylight meets darkness, and we can confirm that darkness with modern day webcams. We can confirm the bright sunny skies with modern day webcams. And that's based off of, you know, a round spherical Earth. And Earth isn't necessarily perfectly round. Like what we see here, you know, Earth, you got to keep in mind, Earth is covered with water, and water is going to camouflage, you know, all of the rough places that Earth has. And Earth is very rugged. It really and truly is. Here's another example. The Earth in between the sun and the moon. And during an eclipse, you can see the curvature of the Earth in the shadow on the moon right there. That's the Earth that's creating that shadow. The umbra means shadow. So when the Earth goes in the shadow of the Earth, that's what creates an eclipse. Umbrella means shade. That's where it came from years ago. When you use an umbrella, the umbrella wasn't even invented for rain. It was by the very name of itself represents shade. So I would highly recommend carrying portable shade, especially if you're in the northern hemisphere in the summertime. But yeah, that's shade, and that shade is created by the planet itself. That's created by Earth, and it's got a curve. This is a couple of different spheres. This is the moon and the sun, but you can clearly see they're both round. That's a partial eclipse from a few years ago. Here's all the other planets in the solar system, and this is just showing that the Earth being like a flat Earth. Everything else is round. We just saw the sun round. We saw the moon round. We've seen evidence of the Earth being round. You know, I don't understand why it would be flat. It just, there's certain mechanics of the Earth that could not work if the Earth was flat, and I'll talk about those here in a minute. Here's another example of, you know, some sort of a disc, flat type of Earth. Again, some of the mechanical things that we look at on a day-to-day basis wouldn't work. Here's the moon, clearly round. These are just a couple of photos showing how rugged the moon is. The surface of the moon is very rugged as well, but Earth is actually way more rugged than the moon. Here we're looking at a big rainbow in the sky. We call these sun halos, and we see these quite often, and they are always round when they're up in the sky like this. But most of you know, because I know you guys are all very smart people, here's a rainbow. Rainbows are round too. You're only seeing half of a rainbow. So whenever you see a rainbow outside after a storm, just know you're only seeing half of it. Rainbows are always full circles. So if the Earth were flat, we wouldn't see full circle, you know, have full circle rainbows and full circle halos. You know, everything has a round personality, round halos in the sky. There's an article, I'll put it down in the description box here in just a few minutes, that talks about rainbows and how they are full circles. They're not just what we see here. There's another entire half to that big structure that we just typically don't see. You can see it sometimes from an airplane. If you're in the sky in an airplane, right place, right time, you can see the entire halo, but from the ground looking up, don't typically see it. But anyway, I just wanted to put that in before we get off into the Earth and what possibly, if the Earth isn't flat, which I don't think it is, what possibly could it be? Here's another view from space. This is the Earth, our little home, traveling through the Milky Way galaxy, covered in water. The planet's 70% water. Actually, it's not 70% water. It is covered and 70% of water. The planet's, you know, solid, has many layers. There's many functions to the planet, you know, the interior of the planet and the exterior, and we're stuck in the middle. We're like right here. There's a lot going on under our feet, and there's a lot going on above our heads. Trust you me. But what's the planet itself? You know, is it a perfectly round, like a drop of water like that? Just looks so beautiful? No, it's not at all. I've actually seen the Earth a long time ago from an instrument that's not even around anymore. And I learned a long time ago that the Earth is not necessarily perfectly round, but it's certainly not flat either. It's more like this here, like a geoid. This is the Earth without water. And see how water hides all of these like valleys and different surface features. Like the red area you see here, that's a gravity anomaly. That's what that's supposed to represent. But it goes from that to that. Okay, if we didn't have all of this surface water, number one, if we didn't have the surface water, there wouldn't be life on Earth. That water is a shield for every one of us on the Earth. It provides a layer of protection. All that blue you see right there, that protects us. Otherwise, there wouldn't be life on this geoid. And that's what the Earth really looks like. It's very rugged, very rough terrain. And again, the water fills in. Like over here, you would have a very deep ocean. Down here around Indonesia and the Indian Ocean, at least parts of it, would be very deep. But, you know, looking at it from the surface, you'd think, wow, you know, that's nice and round and Earth's very beautiful. It is, you know, it looks like a blue star from a long ways away. But again, if you take the water off of the surface, you know, it's an entirely different looking, you know, planet. And there's an ocean under the ocean, believe it or not. There are two oceans. Earth has a surface ocean, and then there's an ocean under the ocean. Do you think that this feature right here doesn't have maybe some cracks in it? The ocean water leaks down inside, and it's created an ocean underneath the ocean. The water that's on the surface is just mainly excess water that wouldn't fit inside. That's really what's going on. That's just what wouldn't fit inside, and that's why we have, you know, continents all over the place, because there wasn't enough room inside the Earth for all the water. But anyway, thankfully so, because like I said, that provides a shield for us. But here's another view of what the Earth looks like. And then I'm going to show you here towards the end of the video of what the national NOAA, what they say the Earth looks like with regard to being a geoid. I'm going to show you what you can actually print this out if you have a printer. Here's another look at the Earth, again, without water. You can see the stress lines. Those would be what we call fault lines. Those are areas where we see earthquakes. The Earth is always in a state of change. It's in a constant state of motion in many, many different ways. And, you know, I think every time there's an earthquake, you know, the Earth is expanding. It's changing a little bit, especially whenever there's a large earthquake. This is what they call a geoid. And to me, this makes sense. You know, any rock, any comet, any asteroid that's ever, you know, made a passage through the inner solar system that we've been able to see and monitor with telescopes and things like that, not one has been perfectly round. Now, I guess if it had surface water, you might get the impression that it's perfectly round, but more than likely, you know, none of them are. Not one. Not any comet, not any asteroid, and not any planet. They're all very rugged. At least the solids are very rugged, rough planets, unless they have surface liquid. In our case, it's H2O, it's water, and it makes it look nice and round. So I kind of subscribe to that theory here, not necessarily this one, and I'll tell you why. You're looking at a replication of a flat type of a Earth, and you know, you don't see the separation between daylight and darkness, and we can confirm that now. We can go on the backside of the Earth at any time, and you can click on a webcam and you can see that on the backside of the Earth, the side opposite the sun, you can indeed see that it is dark, and you can confirm that on the daylight side of the Earth that it is indeed daylight, and you can find the prime meridian, you know, and you can separate daylight from darkness on the round Earth. I mean, if it were flat, you really probably wouldn't be able to do that. Another thing is, I'll bring up a another little map that I put together. And then obviously here I was talking about the daylight and darkness. You know, that would be kind of difficult to do on a flat plane. But looking at the seasons and hurricane seasons and things like that. Get another map up here for you guys. Hang on just a moment, please. It is right here. Okay, this one. As the sun makes its journey between the 23.5 south latitude up to the equator and then up to the 23.5 north latitude, it's that journey that creates the seasons as we know them. You know, winter, spring, summer, and fall. And it also is instrumental in the hurricane and cyclone seasons in the southern and northern hemisphere. And if the Earth were flat, all cyclones would rotate the same direction. As we have it right now, we have cyclones just below the equator. They rotate counterclockwise. That's because of the curvature of the Earth. The storms, hurricanes as we call them, in the northern hemisphere, they rotate counterclockwise. It's because of the curvature of the Earth. And then the seasons are, you know, they're influenced by that same curvature and the sun angle. Everything is about the sun angle too. You know, when it only comes down this low, 23.5, and that's the southern hemisphere's summer. And as it makes its way back up, they go into what they call, you know, their fall season is our spring season up here. Or I'm sorry, their fall is our, spring. And then as the sun gets back up to the equator, that's when our spring starts. Their fall is our winter. And then, we get to March 21st. That's obviously the equinox. That is the beginning of our spring. And then our summer starts June 21st when the sun reaches the 23.5 degree north latitude. That is also coincidentally the beginning of hurricane season in the northern hemisphere. And it's also the beginning of winter down in the southern hemisphere. So again, you know, if the Earth were flat, I don't think there would be anything separating the seasons from one another, you know. Since we live on a round-ish, we live on a geoid. And here's where you can print out a geoid model of what the National Ocean Service, what their definition of the Earth looks like. Print your own geoid. And a geoid is what I showed you guys earlier in the earlier video. Earth just happens to be, you know, a rather large geoid that's full of life, absolutely loaded with life from top to bottom. And here's another, you know, definition of you know, a geoid and the Earth described sometimes as a spheroid, but you don't see anything, you know, about it necessarily being flat, because a lot of these things that we see, and some of the things that I just showed you guys with regard to, you know, hurricanes and the direction that they rotate, either clockwise or counterclockwise, you know, some of that stuff just simply would not work if it was just a flat plane across the board, you know. So here is a little thing I wanted to share with you guys from Aristotle. You know, obviously this is a great philosopher from years ago. Goes back to 384 to 322 BCE. Proves that the Earth is spherical with the following evidence, and this is from Aristotle. He talks too about the lunar eclipse makes a circular shadow on the moon. That's one of many ways you can look. He also said the ships sink on the horizon, and not literally, he's speaking figuratively. When a ship sails away from land and goes straight out to sea, well, once it reaches a certain point, you can no longer see it. Even with the aid of binoculars or, you know, sometimes a good telescope, if you follow that ship all the way out as far as it goes in the ocean, it looks like he's saying here, it sinks. It sinks on the horizon. That's the curvature of the Earth. It's gone beyond the curvature of the Earth from your location, and you just simply can't see it anymore. And another thing too is some of the stars can be seen from some locations on the Earth, but not from others. And we can confirm too, like I mentioned earlier, back then they didn't have webcams on all sides of the Earth. So, you can easily today go from, let's say, Italy, and then hop over to Arizona. It may be dark in Italy and daylight in Arizona, and you can confirm it in, less than 30 seconds. So a lot of different ways we can confirm, a geoid type of an Earth. Hold on just a second. I'm taking a question from Alicia. I have a question about the stars. If everything is moving in space, how are the stars, constellations, the same over the history of the Earth? That's a good question. I know for a fact we are moving. I've tracked stars. I tracked a star that wasn't necessarily on the star map. And I can confirm two things that I learned. I learned that we are indeed moving. Yes, we are. That is a fact. We are moving, and it's exactly as we're taught. It's 365-day orbit around the sun. But one thing I did learn is that our orbit around the sun is not a perfect circle. No, it's not. Our orbit around the sun is more elliptical. I learned that back in I didn't learn it in 2012. I started studying that in 2012, and I figured it out in it was 2016, because I was following a star through the solar system, and it was up in Hydra. And as the Earth was moving around the sun, I could see it in October, and I could see it in March. And there was a 7-month gap between the times I could see it. And look at it like the star that I was following, look at it like a lighthouse that was pointing, beam off into the sky or the space, is pointing in a specified direction. And I had to be in front of the lighthouse in order to see that beam, or a stationary beam. Well, as we moved around the sun, I would see it in 5 months, and then I'd see it again in 7 months. And I'm like, oh, or I should have seen it based off of what I understood about the orbit, or at least what I thought I understood. The orbit's not perfectly round, because I should have seen that star every 6 months, and I saw it in October, and I saw it in March. So yeah, I mean, I learned a lot from that. We are indeed moving, but as far as, the stars and things like that, that's an excellent question. It really is. That's an excellent question. Thank you, Mama Jean. Question from Wesley. I've been researching it for 3 years, and it's flat and stationary. Okay, that's your opinion. I want you to think for yourself, and do your own research and think for yourself. I'm just sharing my opinion with you guys. It's just what I think. I don't necessarily think it's round. I think it's more like this. This is a geoid, and this is, you can print this out. I'll put the link down below in the description box if you wanted to print this out. And they say that if you have, which I don't, if you have a 3D printer, you can print this out, and it will give you a hand size replica, of the Earth, without water, of course. But another thing too about the Earth being, and I have done my research, by the way. So Wesley, yeah, you've done your research and you've concluded it's flat, and I have done my research and I've concluded it's not. And just like I told you about the seasons and the sun moving up and down, I've studied sun angles, I've measured shadows, I've done all that work, my friend, and some. You have no idea the schooling that I've got. You have no idea. But let me tell you something. You have the tropics. The tropics are always warm, and the top and bottom of the Earth are always cold. How does that parlay into a flat system where you have 4 seasons? And you have, hurricanes, and you have cyclones, and you know what cyclones and hurricanes really are? They're heat engines. They're not storms. We call them these cyclones, and they're these machines that are loaded with rain and wind. They just have a job to do. They're moving heat away from the equator of this round object that we live on to the poles. Not something flat. They wouldn't even have a job. I've studied hurricanes for so long, I've forgotten so much about hurricanes. They move heat simply away from the equator of the Earth where it's always hot. Why is it always hot at the equator if it's flat? It wouldn't be. It'd be the same temperature everywhere. So, I humbly disagree. I want you to think for yourself, and if that's what you think, that's great, man. I don't disrespect you for it at all. Yeah, and you know what, JJ, it's not perfectly round. Absolutely not. The Earth is a geoid. It's very rugged. It's very rough. If it wasn't for the water, then you'd be looking at an entirely different type of a planet. Every planet we look at in the sky, we can look at our own moon, which we have one fairly large moon compared to the rest of the moons in the solar system. I haven't necessarily been to any of the other planets in the solar system, but to me, and based off of what I see of Venus, I see Venus through a telescope all the time. And it's always in some sort of a phase mode, like the moon. It wouldn't be if it was flat. I'm not quite sure how that would work, why I see Venus in phase mode pretty much all the time if it were flat. And this, just looking at this picture here, it looks like obviously they're being facetious here, but they've got like a square tile that's orbiting around the sun, unless you think the sun orbits around Venus and Mercury and just kind of does a dance between all these planets here. Yep, they're doing acrobatics in the sky. But no, based off the research I've done, and I've done plenty, trust me, Earth is not perfectly round. It's more of a pear shape, if you want to know the truth. More of a pear shape. Depends on where you do your research. I've done my own research. I haven't read what somebody's told me. There's a big difference. You can say, oh, you haven't done your research. Have you ever been out in the field? Spent many hours out in the field studying your surroundings? I am more than acutely aware of my surroundings. And when I say acutely aware, I am more than acutely aware. I'm not the smartest guy in the world. I don't claim to know it all. I don't claim to be the oracle of knowledge by a long shot. But trust you me, I wanted to figure out where we're at, what we're doing, and where we're going. And I wanted to find out what type of a ship I was flying on. And I learned enough throughout my research, not somebody else's, my own. And I concluded that, yeah, this baby's not necessarily round, but it sure ain't flat. And you're not going to fly off the edge, and it's not circled damp. It's not surrounded by ice. But that's just my opinion, and you're, free to have your own. Now, like I said, I want you to be a thinker. But don't assume, somebody hasn't done their research because I haven't read somebody else's paper. I make my own. I make my own papers. And I rely on myself and my own research. I'm not going to just read somebody else's theory and subscribe to that, and that's gospel. That's just the way it is. No, that's not the way it is. You get out in the field and you create the research, and then you form your conclusion based off of what you have learned. You follow a star in the sky for 365 days like I did, and you follow it religiously every night. You don't miss a night. And you make those calculations and you keep those notes. And you'll learn, you'll figure it out. Don't just take what you're told from somebody else. You want to talk about doing research? You get out and do it. Oh, I haven't done my research. No, what do you mean? I haven't read somebody else's? No, I'm not going to subscribe to somebody else. I have done my research. That's your planet right there. To be honest, it looks more like a very large, rugged pear. If you want to really know the truth. Not literally, but it does have, like this one over here on the right, that's kind of close. I mean, the Southern Ocean is so big. That's the ocean that occupies the bottom of your geoid down here. You know, it's the water that fills in all of these crevices, and you say, oh, the ocean's really deep over there. Well, there's a big canyon over there is really what's going on, a big valley. The Mariana Trench, and there's a big trench over here by Puerto Rico, off the coast of South America, over here by Guam, you know, down by Indonesia. The water is extremely deep in places. The top of the Rocky Mountains, the gravity's very strong up there. And it's just because the water can't get up that high, you know. If the Earth were flat everywhere, the water wouldn't even be deep. But that's just the way I think. And I do know we orbit around the sun, and I think it's a little challenging to maintain a steady orbit. You know, if our gravity was being orchestrated by a flat object, you know, it would be very inconsistent. Yeah. Yeah. How does I wonder how that sun simulator creates like vitamin D for people and ultraviolet radiation. Whoever made that they definitely covered all their bases if that is indeed the case. You know, I measure UV every day. I don't report on it every day, but I measure UV every day. And UV, a lot of people that have done their research, they'll think that the outside temperature is the most relevant number that the weatherman tells you. No, the most relevant number that he doesn't tell you is the UV, the ultraviolet light. He doesn't even talk about it. Every weatherman around the world should talk about that number first. But they don't mention it, right? Right? They don't mention the UV. Well, the UV is going to tell you how healthy your planet is, your ship's shields, you know, that protects you. And those shields, yeah, they have anomalies in them. And if it were flat, you wouldn't have any shields to speak of. But they're stronger because I measure UV have for years. The lower the sun angle, the lower the UV because of the atmosphere and the shape of the Earth. When the sun's overhead, the UV's higher because it goes through a thinner layer of the atmosphere. It's not coming in at an angle, and it's not going through, you know, several hundreds and hundreds of miles of atmosphere. It's going through a few hundred. Because of the sun angle, everything's about the sun angle and the curvature of the Earth. And again, the water is what makes it appear to be a nice, round, you know, beautiful blue marble, and it is a beautiful place. You know, it's Earth is awesome, but it is, you know, got so much going on. From, like I said, we're stuck in the middle here of all this activity that's inside the Earth and above the Earth. The different layers of the atmosphere, they all have a job. You know, the ozone, which is simply O3. It's a layer that protects us from UVC, which is a shortwave frequency. You know, it's a form of like a not necessarily a cosmic ray. It comes from the sun, but we get UVA and B that do come down to ground level and are measurable, and those are the numbers that the meteorologist should talk to you about first, because that tells you the overall health of your planet. Not, well, it's going to be 62 degrees today. Okay, but what about the UV? Do I need to carry my portable shade umbrella? No, that's for rain. No, that was invented for shade. Oh no, I thought it was invented for rain. No, the very word umbra means shade, so it's a shade tool. Oh, they used to carry it years ago to protect themselves from UV, too much sun. We don't even talk about it today. But that's the most important number is the UV. And right now, the UV in the northern hemisphere is pretty high for this time of year. Yes, I've been measuring that because I do my own research. I don't listen to what somebody else says. I go out and do my own. And the UV is extremely high for the northern hemisphere. I was getting summertime readings in February, and I've never had that happen. So, never had that happen. Now, I've actually seen the Earth. I had a chance to a long time ago, and it's shaped more like a pear, really. The bottom is slightly bigger than the top. It's not perfectly round, and it's shaped like a pear. Yeah. But I have done my research, but that's just my theory, guys. And you know what? If you don't agree with it, that's great. You know, I want you to have your own theories. I'm not trying to get you to think, one way or another. I'm just sharing with you the things that I've learned over the years. And, if you don't agree with it, that's okay. That's great. Just a talking point. It's been a topic of debate for many years, and it's not going anywhere. Until all of us accumulate massive wealth and we can go on these voyages in outer space, courtesy of all these people that are developing these space hotels and space shuttles that will take you out into space. And then you can see for yourself what the Earth looks like from, 400 miles up in the sky or whatever. And someday you'll probably be able to go much farther than that. I think they have the capabilities today because during my research, I was filming a star constellation very early one morning. And this was many years ago. And again, I wasn't reading somebody else's work. I was doing my own. And I happened to, by sheer accident, I wasn't looking for it, I saw something come in the atmosphere a long time ago. Not necessarily a long time ago. Where were we at? 2022? Let's say 5 years ago. Close enough. And I saw a big spark way high in the sky. And it just so happened to be where I had my recording device recording. It's Canon Rebel T2i. I had it on tripod on video record mode. And I noticed the spark very high in the sky. And it was directly in the field of view I was recording. I was recording Hydra, just so you know. Hydra is a constellation near Leo. And then I see something, I saw something go past me to my right, and it was a very large, but it was so dark, it was 4:30 in the morning. It looked like a big black boomerang went past me. I'm like, wait a minute, that's what just came in the top of the atmosphere. I'm like, wait a minute, that's just what flew in front of my camera. Guess what? It did fly in front of my camera, and it did get picked up in my video. It was very hard to see, but that craft that made a spark at the very top of the atmosphere came flying right in front of my camera. Yeah, that's a true story. Couldn't believe it. But it's true. And ain't no telling where that thing had been, and I don't know where it went, but it flew past me towards California. That's the direction it flew, towards the Pacific Ocean. I'm in Arizona. Flew over my head, going so fast, I saw it for maybe a grand total of 1.5 seconds. It was flying from east to west. If it hadn't have tilted, I wouldn't have seen it. But it tilted, and that's when I saw it. And the top had these round circles on it that weren't necessarily lights, because I don't think it was meant to be seen. It blended in with the dark sky perfect. But when it tilted, you could see those lights, portals on the top. They were like windows. And the inside of this thing, I'm assuming that's what it was, with light orange. And it was huge. It was a black boomerang. And it flew right in front of my camera as I was researching that anomalous star in Hydra. I tracked it for many years. And I calculated through a 365-day period, and I learned that during that 365-day period, the Earth's orbit around the sun is not perfectly round. Nope, it's more elliptical. But I do my own research, guys. I try to depend on my research, and if it's right or wrong, I stand by it. I don't want to just go with somebody else's research that I know absolutely nothing about. Don't know these people from Adam, and I try to figure things out on my own. And that's what I've learned. And is it 100% correct? Aristotle himself, years ago was basing, again, it's just theory. None of us have been on a ship outside this atmosphere. That's the sad part. We don't get to go outside the atmosphere and view the Earth and, to, really fully understand, where are we? What does this place look like? I really, truly want to see it. And I've done my best with what I've had available to work with down here on the ground to, satisfy my own curiosity that, it's pretty round, it's kind of close, But anyway, that's, like I said, guys, that's just a topic that's been around for many, many years, and it'll be around for a few more until these unbelievable space programs start taking off. And 100 years from now, it probably won't even be a topic of debate. Once everybody gets a chance to go outside and not be influenced by a conspiracy or whatever, you can just go out and see for yourself. Here, boom, here it is. Oh, okay. Wow. It is flat, or wow, it is round, or wow, it is hollow, whatever the case may be. I don't want to argue. It's just a talking point, that's all. But it's probably one, like I said, that won't be a talking point. I'd say what do you think? Maybe 50 years? Everybody will at least have a chance to go for a weekend on a space hotel and orbit the Earth. They're already making them. I'm sure right now they're, terribly expensive, but they are making them right now where you're going to be able to go and rent a room on a very large ship that can escape the gravity of Earth, orbit the Earth, and you'll go orbit the Earth for a weekend and then come back. Now, how cool is that? And then you'll be able to see for yourself. Oh, wow. Like I said, it's one way or the other. But right now, it's still a topic of theory. That's all. People theorize that it's flat based off of other people's research. I'm not going to, do that. I'm just going to do my own. And I'll stand by it, right or wrong. It satisfies me. But anyway, guys, that's all I got for now. Here's another look at the round rainbow. And they are all round. We just don't see all of the rainbow unless you're up in an airplane. And one of these days when, our great grandchildren are able to go to work probably in outer space, they'll get on, some of the ships that are being designed today, and it'll be commonplace just to go work on a hotel that orbits the Earth, And they'll be looking at us saying, yeah, they used to talk about whether the Earth was flat or round or hollow, and they were all wrong. We might all be wrong. I don't know. I'm looking at one more question here, guys. I'm sorry. There's a lot coming through. I'm just trying to grab a few. No, I'm not being condescending at all. I'm just letting you know that I do my own research. Condescending's not who I am. I don't have an ego. I don't look down on people. I look people in the eye. So you got me all wrong. If you think I'm condescending, then that must come from your world, not mine. I am not condescending at all. But I have done my own research. I don't subscribe to other people's research. There's some people that I have respect for, of course, but I do my own. And I've done a lot. It's just the way it is. I have done a lot. And I haven't even talked about a small fraction of it. But anyway, guys, that's all I got for today. Got some really cool things I want to share with you guys coming up, and I might do them in a live stream. I don't know. I've been getting an abundance of videos, and again, it's because everybody in today's world is carrying around a high definition recording device, and you guys are very alert. You are very tuned into your surroundings, and you're always seeing things in the sky. And, you know, when you send things to me, you know, I'm very humbled, and I want to use those things and share them the very best way that I can. So what I'm thinking about doing is maybe putting the majority, because I have a bunch. I just counted before I did this video. I have over 50 different, well, almost 50 different video clips from, I think, 50 different people of things you've seen in not only the nighttime sky, but the daytime sky as well. So I'm thinking about maybe just doing a live stream and sharing all of that content in one video instead of making, you know, 20 videos with 2 each in it. I don't know. We'll see. But I might do a live stream. So I just looked before I did this video, no joke. And I counted, and there was almost 50. One more here, Brian Long. Mr. MBB is deep state. He will lie about Wormwood. I'm just reading a comment here. He will lie about Wormwood. Ask yourself why all the quakes, volcanoes that are going off daily now. It's because the planet. No, earthquakes have been going on for forever. They've always gone on. It's just that now we know about it. We have more monitoring devices around the world. Yeah, there's been an increase in smaller earthquakes because there's been an increase in volcanic activity. You know, a lot of these earthquakes that you're talking about, especially the ones in Hawaii, are from Mount Kilauea, when Mount Kilauea erupted in 2018. And, you know, it honestly hasn't stopped. It's slowed. It's not as strong, but the earthquakes have continued since 2018. There are a lot of earthquakes going on right now. Earthquakes have always gone on. We have a lot of new monitoring systems around the world that are detecting more, just like you people are detecting more things in the sky, because everybody has a monitoring system in their hand at all times. You have a high definition recording device in your hand, probably right now. And you can go outside and take a high definition recording of something in the sky. Everybody is a walking, you know, you have a walking recording device. I have one. I'm holding it right now. That's what I just read that comment on. So we can accumulate more data. That's why I said there's I'm getting an increase in sky observations because you guys are equipped. Everybody has equipment now, where 60 years ago, nobody had equipment. We barely had landline phones. I think we had black and white TV. Our communication, we couldn't communicate with anybody. Now we can communicate with somebody on the other side of the world in a nanosecond. So times have changed, so we're more aware of our surroundings. Just like I said, with the videos that you guys have sent me, they're all really good, and I'll probably share them in one live stream, and I really appreciate it. And keep them coming. You guys are doing a great job. You're very observant. You don't miss a trick. I'm telling you, you guys are very, very acutely aware of your surroundings, and I'm very impressed. I am not at all condescending. I think you guys are awesome, and I know if I want to figure something out, you know, like this here is just my theory. You know, you don't have to agree with me, and you don't have to get mad at me. It's okay. You know, if you don't agree with me, it's okay. You're still my friend. You know, don't be mad. I'm not trying to do that. I respect your opinion. Whether you respect mine or not, that's okay. That's entirely up to you. But I do respect yours. And I do really appreciate the videos and pictures that you guys send in. And I wanted to, I know for the longest time I would get emails probably once a week from people that couldn't attach larger videos to the email. The email is reports at Mr. MBB 333.com if you have any photos. But if you have a large video file that will not fit in the email for whatever reason, you can send it here. You can go to the website. Again, the website's mrmbb333.com. It's right here. I always put a new photo on the home page, and it's got all kinds of interesting, relevant data. This is relevant data to your world, to your environment, to where you live. But the red banner over here, click on this. It will redirect you over here to Dropbox. And you simply attach your video to the Dropbox right here. There you go. If you have something to share, please include your first name, date, and location. And then I'll take it from there. And then just simply attach your video file right there, and then it will come to me. Again, the website is mrmbb333.com. I always have it in the description box of, I think, every video. I put it in every video. But on the website here, there's solar flares, the geomagnetic K-index. We monitor the Schumann resonance, call it the human resonance, every day. Yellowstone, the sun and you, the sun and your health. I'm keeping track of the solar flux over here. If you don't know what the solar flux is, you know, it's just part of our existence here. Incoming solar storms. I'm keeping track of how many X-flares we've got going on as we've entered solar cycle 25. And then if you scroll down, there's another whole list of things. The geospace magnetic field map. Again, if you've studied the geospace and the magnetic fields and how hurricanes are influenced by the north and south poles. I don't know if you knew that or not, but hurricanes in the northern hemisphere, cyclones in the southern hemisphere are influenced by their respective polar regions. Yeah, believe it or not, the hurricanes start out at the equator and they go north. If you'll notice, they all have a common denominator, and that's north eventually. That's because they're being influenced by the North Pole. Cyclones in the southern hemisphere, below the tropics, below the equator, are influenced by the South Pole. Eventually, that's where it steers them, the polar regions. Yeah, they're influenced by the jet streams and the wind shear and things like that, but they are guided by their respective polar regions, whether it be south or whether it be north. So once again, large videos, you can attach them here at the banner that says have a large video. Simply attach it and it'll send it to Dropbox. All right, guys, that's all I got for today. Thanks for watching. Have a super day and be safe out there.